The 9 is built around one central principle. Every result must remain connected to the work and evidence that produced it. A completed game is not reduced to a collection of disconnected statistics. Video, event context, verified pitch data, play-by-play, box score, reports, and review tools remain connected to the same game record. Now, let us look at the 9 review in practice. This is the main read-only workspace for a completed game. It allows coaches and analysts to review the entire game, move between innings, at-bats, and individual events, examine video and game context, and use the available analysis tools without changing the delivered package. The inning selector provides direct access to every completed half inning in the game. By opening this menu, the user can immediately see how many innings were played and move directly to any top or bottom half. There is no need to search manually through a long video. Selecting an inning automatically updates the review workspace and prepares the at-bats and events belonging to that exact part of the game. Inside the selected inning, the at-bat menu lists every plate appearance in its correct game order. After an at-bat is selected, the sequence table displays every logged event from that plate appearance, including the event, the count before the pitch, the base state, the number of outs, the pitcher, the batter, the result, and the pitch type. When runners are present, the runners on base panel identifies who is occupying each base before the selected event. This context comes from the verified event-by-event game record, including the application's rule-based runner movement and any manual runner actions recorded by the analyst when required. The 9 Lab provides a simple way to query the verified pitch data from the current game without writing SQL. The user first chooses the required perspective, pitchers or hitters from either team. This selection defines whose rows will be searched. The source is the completed pitch data CSV belonging to this game package, not an unrelated external database. The user can then describe the required conditions in plain, structured language and export only the matching rows. Here is a simple pitching example. The query asks for fastballs with a release speed of at least 95 miles per hour. The 9 Lab interprets those conditions, searches the selected pitching data, and reports exactly how many rows satisfy both requirements. The resulting CSV contains only those matching pitches, while preserving the complete available context for each row. This gives a coach a focused dataset without requiring manual spreadsheet filtering or knowledge of SQL syntax. The same process can be used for batted ball analysis. In this example, the query asks for contact events with an exit velocity of at least 100 miles per hour and a launch angle between 8 and 32 degrees. The result isolates the contact events that meet both conditions. The exported CSV preserves the complete available pitch data rows for those events, including game context, batter and pitcher identity, count, inning, result, event ID, and video in and out points when those fields are available. The local manager version also includes the 9 Lab multi-game analysis. Instead of querying only one completed game, this workspace can combine verified pitch data from multiple game packages into one controlled dataset. The workflow is divided into clear stages. Choose the games, choose the player and situation, choose the analytical focus, build the dataset, review the results, and export the required output. This current version reads completed games from the local game library. A future client implementation can use the same dataset, contract with authorized cloud packages. The first stage is selecting the team and the games to include. The user can work with all available games, a recent game window, or a specific date range. The system also recognizes multiple saved versions of the same provider game. It resolves those versions so that one real game is not accidentally counted more than once. In this example, Australia has several available games. We select only the games required for the analysis before building the combined dataset. After the games are selected, the user can choose a role, a specific player, an opponent, batter handedness, pitch type, count, inning, outs, and runner situation. Here, 2 games are selected for pitcher Jack O'Loughlin. The Summary tab reports 98 evidence rows, 95 tracked pitches, 25 plate appearances, and 18 batted ball events. Every rate is shown together with its numerator and denominator. This makes the result easier to verify and prevents a percentage from being presented without explaining the sample behind it. After the games, player, and filters have been selected, the Summary tab provides the main overview of the resulting dataset. It shows how many unique games are represented, how many evidence rows remain after filtering, how many of those rows are tracked pitches, how many plate appearances are represented, and how many batted ball events are available. It also calculates the principal rate and measurement summaries, including strike percentage, called strike plus whiff percentage, swing percentage, contact percentage, whiff percentage, average pitch velocity, average exit velocity, and hard hit percentage when the required data is available. For every rate, the table displays the numerator, denominator, and definition. This allows the user to understand exactly how each value was calculated and how large the underlying sample is. The Pitch Mix tab separates the selected pitcher's results by pitch type. For each pitch, the table shows the number of pitches, usage percentage, and the usage numerator and denominator. When tracking measurements are available, it also presents average and maximum velocity, spin rate, induced vertical break, horizontal break, release height, release side, and extension. The results then connect pitch characteristics with outcomes, including strike percentage, called strike plus whiff percentage, batted ball events, average exit velocity, hard hit percentage, and sweet spot percentage. This makes it possible to examine not only which pitches were used, but also how each pitch behaved and what happened when it was thrown. The Game Trend tab separates the combined analysis back into the individual games included in the dataset. Each row represents one selected game and identifies its date, game folder, matchup, and opponent. The table then compares workload and performance through pitches, plate appearances, strike percentage, called strike plus whiff percentage, average velocity, average exit velocity, and hard hit percentage. This view helps the user see whether the combined result was consistent across the selected games, or whether usage, pitch quality, contact allowed, or overall performance changed from one appearance to another. The Recent versus Prior tab is designed to compare the player's current performance window with an earlier group of selected games. It displays the recent and prior values side by side, together with the relevant numerators and denominators. When both groups contain eligible games, the delta column shows the difference between the two periods. This makes it possible to identify changes in workload, strike percentage, called strike plus whiff percentage, average velocity, average exit velocity, and hard hit percentage. In this example, the current selection contains 2 recent games and no prior games. For that reason, the prior values and the differences are correctly displayed as NA. Once an eligible prior group is included, the comparison can show how the recent window differs from the earlier one. The Evidence tab exposes the individual rows behind every summary and percentage shown in the analysis. Each row preserves the available game folder, date, inning, at-bat, pitch number, pitcher, batter, pitch type, pitch call, count, outs, runner state, velocity, exit velocity, launch angle, stable event ID, and video in and out points. This means the user is not limited to accepting a calculated result without seeing its source. The underlying events remain available for inspection, verification, filtering, and export. The evidence count displayed on the tab also shows exactly how many rows support the current analysis after all selected game, player, and situation filters have been applied. The Data Quality tab explains whether the selected games contain the information required to support the analysis. The summary first reports the number of evidence rows, the number of tracked pitches entering pitch rate denominators, how team ownership and player identity were determined, and whether special or non-pitch rows were preserved without incorrectly entering pitching calculations. The coverage table then evaluates important fields across all selected games. It shows how many games contain each field, how many rows are populated, how many rows are actually applicable, and the resulting coverage percentage. This distinction is essential. A blank value should not automatically be treated as bad data when that field was not applicable to the event. The Data Quality tab makes missing, inapplicable, inferred, and fully populated information visible before the analytical result is trusted. The Review Hub turns the completed package into a structured staff review queue. At the top, the package overview summarizes the game record, linked video context, pitch data coverage, contact metrics, reports, team filtering, and read-only status. If a separate package quality manifest was not delivered with an older package, the interface clearly reports that the package was not evaluated, rather than inventing a quality result. Below that, the coach queue organizes qualifying events into practical categories covering contact and power, situational baseball, pitching, defense, base running, and pitching approach. Selecting a coach queue category displays the exact events that satisfy that category's documented conditions. In this example, hardest hit ball ranks the strongest contact events by exit velocity. The selected event is Bobby Witt Jr.'s single at 114.2 miles per hour. Opening the row returns the user to the exact event in the main review window. The video, at-bat sequence, count, result, pitch type, and available contact measurements are displayed together. The category, therefore, acts as a direct path from an analytical signal to the evidence behind it. The selected game stats layer creates a statistical projection from the current processed game package. It can display batting and pitching results for one team or both teams, using the same verified pitch data that powers the review workspace. The header clearly identifies the scope, number of rows, number of batters, number of pitchers, and the source file. These are current package statistics, not official season totals. Their purpose is to connect game-level performance directly with the review events from which those numbers were derived. When a batter is selected, the lower table lists that player's linked plate appearances and events from the current game. For Bobby Witt Jr., the user can see the inning, at-bat, opposing pitcher, result, and stable event ID for each linked appearance. Double-clicking a row, or using Open Event, returns directly to that moment in the main review window. The statistical line is therefore not isolated from the game. Every result can be followed back to the corresponding event and video evidence. The same evidence-linked approach applies to pitchers. After selecting Kyle Bradish, the table displays his current game pitching totals and the events connected to his appearance. The linked event section identifies the inning, batter, result, and event ID for each available plate appearance. A coach can move from the pitcher's summary to the individual hitters he faced and then open the exact review event. This connects workload and results with the pitch-by-pitch context behind them. The catcher receiving report is a transparent, single-game receiving report built from eligible physical taken pitches near the strike zone boundary. The first version uses the Nines defined shadow band, 1 baseball diameter inside and outside the strike zone edge. Pitches in the heart of the zone and pitches far outside are not included in the receiving denominator. Across all catchers in this game, the report identifies 72 eligible shadow band pitches, 39 called strikes, 33 balls, and an observed strike rate of 54.2%. The catcher selector isolates the receiving result for one catcher. For Jack Caglianone, 8 pitches satisfy the current shadow band rules. 4 were called strikes and 4 were called balls, producing an observed strike rate of 50%. This is a descriptive outcome, not an estimate of catcher skill. The number reports what happened on the eligible pitches in this game. It does not yet adjust for pitcher quality, batter, umpire, count, park, league environment, or expected called strike probability. The Zones tab divides the shadow band into directional regions around the strike zone. For each region, the report shows the number of eligible pitches, called strikes, balls, and the observed strike rate. This makes it possible to see where a catcher received called strikes and where similar boundary pitches were called balls. An NA value means that no eligible pitch was available in that zone. The system does not create a percentage when the denominator is 0. The Evidence tab exposes every pitch included in the selected catcher's result. Each row identifies the catcher, inning, at-bat, pitch number, pitcher, batter, handedness, pitch type, count, call, plate coordinates, location source, receiving zone, and event ID. Selecting an evidence row and opening it loads that exact event in the main review window. The coach can then inspect the synchronized video, the complete at-bat sequence, the runner and out context, and the original pitch information behind the receiving result. The catcher-specific data quality view explains whether the selected result is supported by complete and usable evidence. It distinguishes eligible pitches from excluded calls, reports missing catcher or location information, and identifies whether the coordinates came from the provider, the analyst, a mixed source, or an unknown source. This makes the receiving percentage auditable. If information is excluded or unavailable, that condition is reported directly instead of being hidden inside the final rate. As we reach the end, I would like to emphasize one important point. Everything shown in the 9 review begins with the analyst's manual, event-by-event work inside the 9. From that work, the application automatically builds its own verified pitch data, CSV, complete play-by-play, and complete box score. These are not imported as finished outputs from another system. When TrackMan or Hawkeye data is available, its measurements are linked to the corresponding logged events, keeping every result connected to the video and evidence behind it. Thank you to everyone who took the time to watch this presentation. I truly appreciate your time, and I hope you found something useful in what you saw today. Thank you once again for watching.